So is this fine with you, what we were doing yesterday? This makes sense? Okay. Dekho, the thing with deep learning is you most of the times back up by evaluations rather than theory. So before machine learning, or at least in non-machine learning papers like algorithms or any other things, you will see things very much substantiated by theory. Okay. Here, even if things they don't make sense in theory, right? But if in evaluations they work well for you, you don't really try to go into these kind of questions ki this is not theoretically sound and blah blah blah. Okay. What here you care about, so in machine learning what is it that we care about? That one line which I told you in machine learning course. Huh? That was AI. Machine learning. Huh? Generalization. So if you don't remember anything in machine learning, you want to generalize well. Okay? And this is what you care about. So if you're anything that you are doing, if it doesn't look theoretically very sound, but generalizes well on your application, right? This is what you were looking for. So everything that authors have done here, for example, this negative sampling and everything, they might seem counterintuitive to us, right? But we are just thinking. What authors have actually done is went off with these ideas, written the codes, trained billions of pairs on it, evaluated it, and then they show it works. Okay. So we just sitting here in this room can't simply question things which someone else have evaluated so rigorously. Okay. Now, so today's agenda. So firstly, by the way, you guys get recorded when you pass from here. Okay. So most likely he won't be. If you go this, if you take this path, then you get recorded. If you take this path, you don't. Huh? Okay. No. I am getting recorded until somewhere here. Alright, so let us start. Alright. Alright, so let us start now. Subsampling of few words. Okay, so one last time maybe. What is it? By the way, when this mic stops working, if at all, let me know. How many neurons in the first layer? Mod V. How many in the output? And how many here? So we keep it 300, but now if you want 1000 dimensional word embeddings, then you keep this number to be 1000. Okay. Now I want everybody to see it clearly. All these neurons. So if I ask you which word embedding corresponds to word, first word in my vocabulary, which word embedding? So let me finish the question. The question is which word embedding corresponds to my, which vector corresponds to word embedding of my first word in this vocabulary? First word in the vocabulary. Yeah, I have sorted it lexicographically. That's how I am keeping it here. So these ones, right? So in this training, what essentially are you learning? This weight matrix and this weight matrix. What is the size of W1? 300 cross 10K. What is this one? Sorry, mod V cross 300. Okay. So both sides you have, this is the same word as it was here. So you are learning these numbers as well. We call this kind of vectors V and we call these kind of vectors U. Okay. Now, what did we do in negative sampling? We said if this is the right word, I am going to choose k negative samples. Okay, so this is the right one and these are my negative samples. How does it help? I mean, how many of you can visualize the training, what is going on? So, I mean, this is the last class before this long weekend, so I don't want to go to the new topic, which will be glove in our case. How do you think this training thing helps us? Can anybody find a very rare word on their mobiles? Very rare word that nobody sitting here has heard of. Try it out. Huh? You have heard it? No. Give me a different one that nobody has heard. Leave that. Yeah. Tell me. Nahi. VHA. What does this mean? But see, I am looking for really rare word. Something that you have heard is not rare, na? Huh? Okay, but I don't want to write this one. Tell me this one. ACCISMUS. What does it mean, by the way?
Pretending to be disinterested in something when you actually want it.
Okay, when you actually wanted is okay. All right. So now this word. Tell me one thing. Assume, for the sake of good calculations, assume our corpus is 100 million in size. Okay. Now, if corpus is 100, having 100 million words, how many theirs will be there roughly? 7 to 8%. So roughly, let's keep it 7. So out of these 100 million words in my corpus, 7 million will be there. Now next one is probably off or something like that. Okay. Now off is somewhere around 3.2, 3.8%. So let's say 3.2 million. You make this list. Okay. What is wrong with this? So when I will be choosing center word in my corpus, I will be iterating over all these words. What is happening here? Words like the, this will become center word how many times? 7 million times. All right. Words like off and so on. And words like this, they appear very few number of times in my corpus. Now let's say this word is somewhere here. So let's say this is that word. Okay, this one. When are you going to update the weights corresponding to this word? When will you update? No, in which case will you update weights corresponding to this word? When it will be there in your example? When will it be your example? When it will be sampled in a pair. But this poor guy appears, let's say, only 3 times in this 100 million corpus. Let's say 3 times. So how many total examples you will have? So this is 3 times. So let's say window size is 2. So every time it is center word, it appears 4 times. But it is going to be in context for other words too, right? So roughly how much? So it will be in context of first, second, third, fourth. So 24 times total, 24 pairs, whereas words like there will appear in millions of pairs. What is wrong with this? Under representation of words like this. Tell me, what is the word embedding of her? What do you actually want? So, let's say these two words. What will be the word embedding of this word? What do you want to capture from this? The semantics of word good, opposite of bad, probably less having less goodness than excellent and so on. Okay. What do you mean by her? Apart from maybe a human being, gender assigned, what else? If I say a sentence, person X is in my class, right? So that person X could be any one of you, any of the ladies sitting here, okay, any of the girls sitting here, and her can belong to, if I am talking about Jivisha is a student in my class, okay, and then if I say something her, in this case her captures belong, right? But if I take some other name, then her. So these things like pronouns, things like that, what do you mean by that? What does that mean? No. What does that mean? Right. So we are not linguists. We will not go into very much detail of this, but we are confused. And such a word is appearing millions of times in my corpus, right? So, but if you are running this algorithm, would you like to learn good word embeddings for these kind of words too? This guy is somewhere here. How many times these numbers will get updated? 24 times. So you start from random initialization, you update this only 24 times. Somewhere here you have the, and you update these weights millions of times, right? So what do we need to do? We need to do downsampling of words like the, and so, and in a way we want to have an effect of increasing weightage of these guys. Okay. So what they do in this case now is they use a formula that I am not going to write here. You can go through my other YouTube videos. There, what they do is that they try to, so the curve that they follow, it is something like this. So here you have frequency. So if some word has 0.1, 0.2, let's say 0.1% frequency, right? You reduce its percentage. So in the paper what they say is there appears 7 million, basically 7% of the times. So you are going to take only 12% of these in your corpus. So if there are 7 million thus in your corpus, you are going to take only 1 million roughly, which is like 14%. Okay. Decreasing these, and they do it only for the first 27 words, only first 27 words. For remaining, they keep whatever number occurs. So this way they are downsampling this so that this noise reduces a bit, and it also has an impact of improving word embeddings for words like this. Okay, so they have done a lot in these two papers. Now, does this make sense? What are we doing here? Okay, so now, what more issues can be there? Think of any other issues which you think this is not capturing this is not capturing that. So how will you use these two? So this is for V, the first one, okay. This is U1. Which one do I use? Which vector do I use as word embedding, V or U? Hmm? Word embedding pairs? Why? No. V is a input word embedding of that same first word. U is the output word representation of that same first word. Which one do I choose? I have two representations for one word. Output? Anything else? See, machine learning, deep learning is more about imagination. So when you say output, you are not imagining anything. So there are many ways of doing it. If you want to say output, you can do that, right? Unless somebody comes and shows that there is another way of improving results. If you use U, fine. If you use V, fine. What else you can do? You can take average of both. Just take average of both. Or what else you can do? Concatenate V and U. So you have these three numbers coming from V and these 300 numbers coming from V and these 300 numbers coming from U. So you can do all such sort of things, whatever works for you and is computationally feasible for you. Right. So we are done with word2vec. Now tell me, what are the downsides, what are the shortcomings? Word2vec achieves a lot, but of course it leaves a lot of questions unanswered too. And actually they try to solve those two, lot of them. So for example, okay, I'm yet to do that.
उससे अगर ट्रेन करना है डेटा को तो जिनका वन है डायरेक्ट उन पे ही ट्रेन करते हैं मतलब ये एक्स्ट्रा जीरोस भी लेने की क्या जरूरत है?
I don't get this.
मतलब जो नेगेटिव्स एक्स्ट्रा जीरोस ले रहे हैं चार पांच भी ले रहे हैं वो भी लेने की क्या जरूरत है? हम डायरेक्ट जो जिनकी वैल्यू वन है उन पर ही मतलब जैसे अगर हमने गुड लिया डायरेक्ट जिन 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 फैक्टर्स की वैल्यू वन है उन पर डेटा
Right, but we have talked about this, right? Why? See, you need to, so if you take only positive pairs, right? I mean, see, one, you want to have more pairs. Second, you also want your system to be able to see, if I give you only context pairs, I don't really learn about what are the words which are not in context. So you want to give both these flavors.
बट अगर हम डायरेक्ट ही जितने पेयर्स पे ट्रेन करेंगे तो वो ज़्यादा अच्छे से ट्रेन नहीं होगा एज कम्पेयर टू मतलब इसमें भी ट्रेन होगा बट अगर हम डायरेक्ट ही जिनकी वैल्यूज वन है मतलब जो एक्चुअल में एग्जिस्ट करते हैं विंडो में उनके एम्बेडिंग्स दें तो वो ज़्यादा अच्छे से
Okay, you are taking me ages back. Um, Remember, I had somewhere said if you take this dot product, you can do. Works now? So, fine? Alright. See, this is what we were looking. This side. Hello? If you are just looking for this guy to be 1, okay, or 0, this is what you are saying, okay, you just want to have a sigmoid. So, somewhere here, you are saying we just want to have this one. What was wrong with this? So, if I do something like this, guys, what will be the, can you help me write? What will be the vector dot product? U quick transpose V fox. Okay. Now, and in order to be this classified well, what do I need to do? Classified well means this is 1 upon 1 plus e to the power minus of this, right? So, what I want this number to be? Huh? So, infinity is not needed. Anything more than 10 for all practical purposes is going to make this 1, right? So, what will your algorithm do? All it will do is this dot product should be greater than or equal to 10, let's say, whatever number you choose. It has moved away from its, it has moved away from our intuition of using it for, learning good word embeddings. What it is learning now? I will like to maximize this dot product, barring this minus. So, I would like to minimize this whole thing, this whole expression, right, and maximize the dot product. So, this has nothing to do with word embeddings now. हाँ, तो फिर क्या? Right, हाँ.
हम अभी देख रहे हैं कि कॉर्पस में वो अवेलेबल है तो उसको 1 देंगे और फिर कॉर्पस में अवेलेबल देंगे तो उसको 0 देंगे.
No, okay, चल, but continue. हाँ.
उससे तो हमें ये चीज मिलती है कि ये जो वर्ड्स है ये कॉर्पस में अवेलेबल है तो इसकी अपियरेंस की प्रोबेबिलिटी ज्यादा होगी. लेकिन अगर हम ऐसे करें कि हम ये देख लिया ये एक अलग सेक्शन और अगर हम ऐसे देखें कि अगर ये जो वर्ड्स है ये कॉर्पस में सारे अवेलेबल ही है और उन पर ट्रेन करें.
सर मतलब शायद पूरे होल कॉर्पस की जगह सिर्फ वो विंडो साइज लेने की बात है वही.
Can we take this offline? है ना? Okay, चलो. Because if it is not even this, then I am not getting it properly. And we will try to answer these questions when we'll come to transformer architectures, which are actually used in GPT kind of models. Okay. Now this is done. So subsampling of frequent words is done. So what about this kind of a phrase? Tell me, what would you like to learn in this case? I wanted to go to Las Vegas, but I ended up reaching New Delhi.
सर आप ही था.
Yes. Las in itself will have a meaning, or Las Vegas? New. So is this New Delhi a combination of new plus Delhi, or New Delhi in itself should be a kind of word? Right. So this is what they also do. They look for the frequent phrases that appear in English language. So this is not a paper. This is, granth. All right. So they look of. Now What more? So I did not like Philadelphia. I am talking about the city or movie. And of course, there are so many words with multiple meanings. What are they? I mean, there are many. For example, bank. So you will learn just one embedding for bank, but bank may mean a financial institution or a bank of a river. Now these two have absolutely nothing to do with each other, and so on. So there are so many limitations here, but despite all this, why we say word2vec is a seminal paper? Now if I ask you this question, let me first think, I always make mistakes here. So what will come here? And after learning word2vec embeddings, even their system could predict queen. Okay, so that means, see, what is the challenge with words? To human beings, words means they carry a lot of meaning, emotions and everything, right? But to machines, it's just a representation, just numbers. So if you are able to capture these kind of meanings, then your embeddings are actually doing something useful, meaningful. So how do you compute this now? So assuming this is my origin, so assuming this to be origin and these are my coordinate axes, let's say this is okay. रिकॉर्ड हो रहा है. So this is my, so let us just have this now. Guys, all I am trying to do is vector addition here. So help me out. So this one, every time I do this and every time I forget this, huh? That is what we are doing.
ये वाली जो लाइन है वो क्या कहते हैं?
Right. So I am there. Huh. Okay. So these are the three vectors that are given to us. What does it mean, three vectors? Because you are given three vectors actually. Okay. Now question here is how to compute this one here. What do you expect? So if these are vectors, what do you expect? So something like king minus man plus woman. Okay. So what is king minus man? Tell me first. No, which vector here? So this guy is man minus king. No, king minus man. Okay. So king minus man is this vector. Everybody agrees? Okay. Now plus woman. So plus woman, and as you know, vector addition, you can actually take that vector. So see, technology allows me to, it does not. So select okay, it does not allow me. So what you can do is you can simply take this vector here. Anyway, whatever it is, so this woman is taken here now, right? Now what addition? Right, addition. So king minus, so this is this the vector I am looking for? Right? No, king minus man plus woman कर तो चुका हूं यार, क्यों अलग से करा रहे हो भाई? So I'm here, right? Now what is this whole vector? This one, right? Now is this queen? Of course not. I mean, you have to be, extremely lucky if that were queen. What you start doing here is, you reach here, you start searching for neighborhood. You start searching for neighborhood. Whichever vector comes first, it turns out that vector is queen. Okay, so it is not exactly this, but what you do is, once you reach to this vector, right, keeping that as a center, start expanding, and the first vector that you hit, it turns out to be queen. Okay, and this they did not just for these kind of vectors. You can find it on the internet. You'll find a lot of examples, like if you say New Delhi is to India and then Paris is to what? It will tell you France. So this is country capital, or currency and countries and a lot other things. Okay, so they had explicitly shown that the word embeddings learned by them actually, they make sense. They also did it for newspapers. So for example, New York Times, then you say Los Angeles, question mark, and it will give you the most famous paper in Los Angeles, and so on. Okay. So this word is, so this is not exactly queen. This is the thing that you need to know. This is not exactly queen, but keeping this as center, when you start expanding, right, it turns out that the first vector that you hit in your data set, that turns out to be queen. So you have to do some kind of search here. This is not exactly equal to. Okay, so what else? Let me see if something is left. Bolo.
सर क्वीन वाला ओरिजिन से क्यों आया? क्वीन वाला वेक्टर
No, man, every vector is coming from origin.
सर वही पूछ रहे हैं.
Woman,
सर वो तो किंग माइनस मैन है ना.
king minus man is this, plus woman plus woman. So this vector is what we are talking about.
अच्छा वो सर्च किया वो इधर सारे और सुपर वेक्टर और इधर सारे सर्च किया तो क्वीन वहाँ से मिल रही पर कहीं और से भी तो मिल सकती है क्वीन का जरूरी थोड़ा इधर से हो क्वीन पर अपन तो रिलेशन तो बात ना सर ये बोल रहा है कि वो किंग माइनस मैन आपने जो किया
See, actually I have not done it properly. What usually it happens is, so if this is king minus man, what you would have here is, this should be queen minus woman. So this parallelogram kind of relationship is there. Okay, so let us try to do one thing. No, I might be doing mistake because no big deal. Sorry?
किंग और मैन का जो रिजल्टेंट आया किंग माइनस मैन उससे बनेगा ना क्वीन वाला वेक्टर तभी वो किंग माइनस मैन प्लस वुमन होगा अगर आप वेक्टर एडिशन
Okay, you are okay, I see. Right, but wherever you reach, you will have to finally take it from the origin, na? See, king minus man plus woman. Okay, so king minus man plus woman is a vector, right? So every vector, I mean,
मतलब उसको शिफ्ट करा जैसे वुमन को किया वैसे ही आप अगर उस वेक्टर को ओरिजिन
exactly, exactly, right. So it's not that it is this. So king minus man was this, then woman, then this vector, but you shift it such that the tail is origin and wherever that woman head lies. Okay, if you start expanding from that place, that basically is, this is something I did not want at all. I'll have to cut this one. More questions now.
word2vec की और कोई शॉर्ट लिमिटेशन है शॉर्टकम
See, one of the biggest limitations is, no matter what they claim, but those words which are really rare, their word embeddings is not really good. And this is understood because if as a human being I don't understand what does a word mean, right? So if human beings don't understand, it's okay for machines to not understand that in some sense. Alright, so they do a couple of other things too. What they do is that they don't keep their window size static. They say we choose window size equal to, so what they do is, so let's say choose window size is C, right? But in their code what they do is they don't take the C. So let's say they take C to be 5 and then they say there is a uniform probability of 1, 2, 3, 4, 5. So for any center word you can have a window size of 1, 2, 3, 4 or 5 and so on. I mean a lot of other things too. Questions? Or else, okay, no, I am not done. So now we did not talk about the Seebaugh model. So in word2vec, So this was our center word, and keeping window size equal to 2, these were our context words. In the same paper they try the other part of it too, which is CBOW stands for continuous bag of words. So in this case what they say is, you have quick, brown, jumps over. Okay. So if this were skip gram model, how many pairs of training examples will I create? 4. Okay. In case of CBOW model, so this is again, okay, let me not do this right now. In case of CBOW model, your training example will be quick, brown, jumps over, comma, fox. So for CBOW model, there will be one training example constructed for every word. In this case, what is happening? Can you tell me? What is the idea behind this?
प्रोबेबिलिटी मतलब मिल जाएगी कि जब ये 4 वर्ड आएंगे तो इनके साथ ही तो होगा ही।
So the thing here is, this is our center word, you remove that center word. Quick, brown, jumps over. These are your input, and then you try to guess what is the center word. So kind of a fill in the blanks kind of thing. Given 2 words this side, 2 words this side, what will be there in the center? So how will I make my architecture for that now? Yes, good one. So what are we doing here? Same architecture works. Mod V, (300), mod V. But how many ones will be here in this case now? There will be a 1 corresponding to quick somewhere here, brown somewhere here, jumps and over. So all these guys will be 1. And this side only for fox. And we are not going to talk about any optimizations on this one. All you need to know is, given these words, this is supposed to be my output. Right. And why is it called continuous bag of words? Why bag of words? See, in this architecture, once you are given this, once you are giving this as input to your model, anywhere are you able to tell me that the phrase was quick brown fox jumps over just by looking at this? So it is bag of words because you are simply saying 4 words, middle word is this one, but what is the order of those 4 words? We are not capturing that in the model. Ideally, I should have covered it as quick, brown, fill in the blanks, jumps, over. But this is not what your model is capturing. All it is saying is there are 4 ones. Which one follows after which one? That is something that we are not capturing in this case. RNNs could do this, but I don't think I'll be doing RNNs in this course. I think it is done for today. Thank you.